Hello, ladies and gentlemen. We're going to be talking about standard 6.G.2. 6.G.2. That's the geometry standard, and it says that we should be able to find the volume of prisms. Now, one of the defining characteristics of a prism, something that makes a prism, is that it's going to have two parallel faces. So I'm going to just outline these in this diagram right here. Parallel faces are going to be faces that are going to be congruent, means they're the same size and same shape, and they're going to be opposite each other or parallel. So I'm kind of highlighting these two parallel faces here. I don't know if you can see those very well. We should try a darker color here. These are what we would call parallel faces. All right, and what that means is that these will create layers of volume if we were going to fill up this box. I'm calling it a box because it's just simple description of it. So we call these things the base, right? These opposite parallel faces are the base. And to help us understand that, I've tipped this thing on its side, and now the base layer is facing up, right? We call this what you might call the top face, right? This is the top face. And down below, the bottom face is on the ground. That makes it easier to understand that this is the base layer. Okay? And so now we can see that these are going to create layers of cubes, right? So the base layer concept is very important because if we can find the area of this top face, right, or even the bottom face, depending on which one we're looking at, but it looks like we're looking at the top face, then I can start to find its area. And if I can find its area, then I will know how many cubes will fit in one of these base layers. Now, this is a composite figure on the top face. This top face is a composite figure. It's a rectangle and a triangle. So I'm going to try and just show you that these would be different. Now, I'm not drawing these according to the dimensions you see labeled. I'm just kind of make a grid here so you can see that we're talking about area. And this area tells us the volume of one of these base layers. Right now I'm kind of drawing this in a three-dimensional way. These are all cubes. Okay? So what this means is that to find the volume of this figure, this prism, I'm going to try and find the base layer, how many cubes will fit in one layer, and I'm going to multiply that by the height, H-E-I-G-H-T, the base times height. Right, that is the formula for the volume of a prism. So I'm going to write volume equals base times height. Now that's for a prism only, not for spheres or cylinders or, well, yes, cylinders. Sorry, spheres or pyramids. There's different three-dimensional figures out there. But for prisms, the volume equals the base times the height. So, and the other thing we need to remember is that the base is different for each prism. Now, this is a pretty funky prism. It has this composite figure for a base. So, I'm going to erase this real quick. I need to figure out how to find the area of this, and then I will know the base. So let's get started. Looking at these dimensions, it looks like the rectangular part is going to have a height of 5. Hopefully you can see that. I just kind of colored over it. It has a height of 5. And so I'm going to write that as 5. We'll call that I called it the height, but we'll call it, for a rectangle, let's call it the width. And this will be the length, and it has a length of 8, 5 times 8. Right? That's the rectangle part. The triangle part is going to have the remaining height. So if this part is 5, the remaining part here is going to be 6, right? Because 5 plus 6 equals the total of 11. So the triangle has, we'll call it the width of 6 and a length of, and the length of the triangle is still 8, so 6 times 8, and we're going to divide that by 2. I'm going to get this in a different color here. This is the triangle, and we'll call that 6 times 8 divided by 2. All right. Now, if I add these two together, I will get this shape, right? This base face or parallel face. And then I'm going to have to multiply that by the height of the prism, right? So the height in this case is 17, right? So this would be the 17 right here. That would mean there were 17 layers, right? So I'd multiply that by 17. So let's find out how many squares are in this top face. That'll tell us how many cubes are in the base. All right, so 5 times 8 is 40, and 6 times 8 divided by 2, I'm just going to simplify this, so this becomes 3 times 8, and that's 24, plus, well, actually, I take that back, right? That's the base. That's just the base, so we're going to stop right there. And then we're going to multiply it by the height, which is 17. 17. So I'm going to have to do a little, well, I mean, combine these two things together here. This is going to give us the base layer is going to have a volume of 64 cubes, right? So in here there are 64 cubes in one of these layers. That's the area of the top face, so that's the volume of the base. And then I'm going to multiply that by 17, because there are 17 layers, right? Here we'd be counting 1, 2, 3, 4, 5, 6. I'm not going to be able to fit 17 in there, but you get the idea. And each one of these would also, that layer would extend this way also. Okay? So let's multiply that. I'm going to need a little scratch paper here. I don't like to revert to scratch paper very often, but 64 times 17, we're going to get an 8, a 2, a 44, a 0, and a 6, and a 4. Let's see, what does this make? 8, 8, and 10. So this is going to equal 1,088. And what's our units here? It looks like inches. I haven't scribbled this up too badly. Inches, and we're talking about volume, so I'm going to say inches cubed. 1,088 inches cubed would be the volume.